Welcome back to the deep dive. If you've been anywhere near a news feed or caught a recent conversation, you know the buzz around artificial intelligence is absolutely pervasive.
It's everywhere, isn't it?
It really is. There's this undeniable, overwhelming demand for AI talent, for experts who can unlock this transformative power. But here's the critical challenge, and it's a confusing one. The landscape is also saturated with self-proclaimed AI gurus, and, well, a surprising number of AI projects end up failing.
hmm
This creates a real strategic dilemma for any organization or individual trying to navigate this brave new world.
It's true. While the demand for AI expertise is skyrocketing, the clarity around what true expertise actually means is often incredibly elusive. It's like trying to find the real architects in a crowded room full of people just holding blueprints.
That's exactly. And that's precisely our mission today. We are going to cut through that hype and provide you with a clear, multifaceted framework for validating genuine AI expertise. This isn't about collecting a single shiny credential or a buzzword bingo card. It's about understanding the foundational pillars that uphold real knowledge, the nuances of specialization that truly differentiate, the undeniable proof of impact, and the critical role that organizational context plays in making any AI initiative succeed.
Absolutely. The context is key.
Our aim is to give you a genuine shortcut to being truly well-informed on what AI expertise means today.
And this deep dive, it draws directly from a comprehensive report designed to provide a critical review and validation framework for AI talent. We've meticulously distilled the most important nuggets of knowledge from that material to help you discern true capability from, superficial understanding.
Okay.
Think of it as your expert guide to spotting the real deal in a world full of AI noise.
Okay, let's unpack this. We're starting our deep dive by looking at the absolute bedrock of AI expertise, the foundational pillars. And the first one, perhaps unsurprisingly, is the unchanging, indispensable role of formal education and academic rigor.
Indeed, a deep theoretical understanding of intelligent systems is the absolute bedrock.
Yeah.
When we talk about formal education here, we mean rigorous disciplines like computer science, mathematics, statistics, or related engineering fields.
Right.
These aren't just checkboxes on a resume. They provide the essential, non-negotiable foundation that underpins all advanced AI work.
So why are these particular fields so critical? I mean, isn't AI all about coding and building things these days? Can't you just sort of pick it up as you go?
Well, you can learn to use tools, sure, but these foundational programs instill fluency in the core mathematical languages of AI. We're talking linear algebra, calculus, and probability theory.
The heavy stuff.
Exactly. Without these, you're essentially trying to build a complex structure without understanding the physics of its materials. They are indispensable for truly comprehending, adapting, and innovating with machine learning algorithms at a fundamental level. A formal degree signifies a structured, rigorous curriculum, not just a piecemeal collection of skills picked up here and there. It means you've engaged with the material comprehensively, understood its origins, and can reason from first principles.
That makes so much sense. It's like knowing why something works, and not just that it works. I remember a time when it felt like you needed a PhD just to get your foot in the door in AI research. Is that still largely the case for everyone?
Historically, yes, a PhD was a near prerequisite for senior AI research roles. And that remains largely true for what we call AI research scientists, those who are genuinely pushing the boundaries of the field, developing novel algorithms, and, advancing the state of the art.
Right, the real innovators.
But here's where it gets really interesting.
Mhm.
The landscape is evolving. The maturation of AI tools and the proliferation of powerful open source frameworks have significantly democratized the field.
Okay.
This has created viable paths for individuals with bachelor's or master's degrees, particularly in more applied roles like AI engineering or machine learning operations, MLOps.
MLOps, yeah.
So while the PhD is still king for pure research, it's not the only path to a successful and impactful AI career anymore.
That's a huge shift in access. Really opens things up. And what about the prestige of the institution itself? Does that still carry weight? The Stanfords, the MITs?
Absolutely, it does.
Yep.
Degrees from top-tier universities like Stanford or MIT are still very strong validators. This isn't just about brand recognition, though, that plays a part.
Sure.
It's because these institutions have uniquely demanding curricula, and they immerse students in cutting-edge research ecosystems, providing access to leading minds, unparalleled resources, and a network that's, frankly, hard to replicate.
Mm-hmm.
So while you might get foundational knowledge anywhere, The depth, rigor, and exposure at these top programs are unparalleled for certain career paths.
So if you're trying to understand someone's AI expertise, that formal education really demonstrates a foundational commitment to the discipline. It
Hmm.
shows they have a capacity for the abstract mathematical reasoning that is truly non-negotiable in AI. It's the theoretical scaffolding for all practical skills, right?
Precisely. It's the foundational logic and analytical rigor that allows someone to not just use AI models, but to understand, adapt, debug, and innovate with AI, especially when confronted with novel or complex problems.
Okay, that covers the academic bedrock. But then you have this absolute explosion of certifications, online courses, boot camps. It's a real maze out there. So, how do we navigate this certification landscape? Are they all equally valuable, or do we need a filter?
You're right to call it a maze, because not all certifications are created equal, and that's a critical point for validation. While they can be valuable signals of specific skills, a critical evaluation of their rigor, relevance, and intended audience is absolutely vital.
Okay.
The market has segmented itself into distinct tiers, each serving a different purpose, and understanding those purposes is key.
Interesting. So let's break down these tiers. What are foundational or awareness credentials? What do they really signify? Are they just, participation trophies?
Not exactly trophies, but they serve a specific purpose. These are generally designed for non-technical or tech-adjacent professionals. Think business analysts, project managers, or even marketing leaders.
Right, people who need to understand AI, not build it.
Exactly. Their primary goal is AI literacy,
Got
helping these professionals understand core AI concepts, common use cases, and the broader implications, like ethics. They're not about hands-on proficiency in building AI.
Gotcha. Any example?
Sure. For instance, the AWS Certified AI Practitioner is for individuals who use AML solutions, not necessarily build them. Similarly, DataCamp's AI Fundamentals validates foundational knowledge without requiring programming.
Okay.
They're good starting points showing someone's commitment to understanding AI, but they are not markers of deep technical expertise.
So if someone presents that as their sole AI credential, it tells you they're AI aware, but not necessarily an AI builder or deep practitioner. Makes sense. What about the next tier, the vendor-specific ones, like the Azure or AWS certs?
Right. These validate proficiency in a specific cloud provider's AI stack, like the Microsoft Certified, Azure AI Engineer Associate, or the AWS Certified Machine Learning Specialty.
And these are valuable.
Incredibly valuable, even critical for roles focused on deploying and managing AI solutions within that particular cloud ecosystem. They demonstrate practical, platform-specific skills.
But there's always a but, isn't there?
Well, the but is crucial. They don't necessarily prove a deep, platform-agnostic understanding of underlying AI theory. An expert proficient in Azure AI services isn't automatically proficient in the theoretical nuances of algorithm design beyond that specific vendor's toolkit.
That distinction is important. They're highly practical within a certain environment, but maybe not universally applicable theory-wise. Then we get into what sounds like the more serious stuff, advanced academic and professional certificates. Tell us about those.
These are often offered by elite institutions, like Stanford or MIT, sometimes online, but often with rigorous coursework. They represent a significant investment of time and money, and they signal a deep commitment to mastering the subject.
So these are more like mini degrees.
In a way, Stanford's Artificial Intelligence Graduate Certificate, for instance, is academically rigorous, with demanding prerequisites in mathematics and programming. These certificates are powerful validators because they truly combine theoretical depth with advanced application, often carrying academic credit and sometimes serving as a bridge to a master's degree.
Okay.
They are a strong signal of high-level expertise for experienced professionals seeking to specialize.
So a lot more rigorous than just the foundational ones. It definitely carries more weight. And then there are the platform-based technical credentials. You mentioned Coursera, Andrew Ng. What do those signify?
This broad category includes certifications from online learning platforms like Coursera, often in partnership with industry leaders like IBM or academic pioneers such as Andrew Ng from deeplearning.ai.
Andrew Ng is a huge name, yeah.
He is. And these programs provide structured learning paths for specific in-demand skills, such as proficiency in TensorFlow, PyTorch, or deep learning fundamentals. The credibility here is often tied to the reputation of the instructing entity.
So Ng's courses are well regarded.
Very much so. Andrew Ng's specializations are highly regarded within the industry due to his pioneering role in democratizing deep learning education. They offer a strong path for developing practical skills.
So with all these certifications out there, what does this shift mean for how we perceive their value? It sounds like a single credential isn't enough anymore. Is that fair?
You're hitting on a key point.
Eh,
As foundational credentials become commoditized, their standalone value for senior, impactful roles really diminishes.
right.
Employers are increasingly aware that passing a multiple-choice exam on AI concepts is fundamentally different from successfully architecting and deploying a production-level AI system.
Yeah, one is theory, the other is practice under pressure.
Exactly. This reality means organizations need to look beyond the certificate itself and seek higher-order proof. This brings us to a crucial concept. A credible expert needs what we call a credential portfolio.
A credential portfolio. I love that framing. So it's not just one thing, but a strategic collection. What would an ideal one look like to really signal expertise? How does that work?
Well, an ideal portfolio might combine, for example, a rigorous computer science degree that validates the theoretical underpinning with a vendor-specific cloud certification like AWS or Azure, which validates practical cloud deployment skills.
Okay. Theory plus platform practice.
Right. Then, perhaps add an advanced specialized certificate in a niche area like reinforcement learning, which validates deep niche expertise.
So you get breadth and depth.
Exactly.
Yeah.
This demonstrates a T-shaped skill set. Broad foundational knowledge complemented by deep specific expertise. It's about the synergy of their qualifications telling a coherent and compelling story of their professional journey and capability, not just a random collection.
That's a fantastic way to frame it. It moves beyond just a list of acronyms on a resume. Now let's get down to the brass tacks, the core technical competencies. What's the non-negotiable toolkit an AI expert absolutely must have to translate all this knowledge into action?
Yeah, the practical skills. The insight here is that while the field diversifies, certain technical competencies remain the universal language of AI development.
Okay, like what?
First and foremost is programming proficiency. And really, that means Python. It's the undisputed lingua franca of the AI community.
Everyone says Python. Why is it so dominant?
Its simplicity, its vast ecosystem of libraries, think NumPy, Pandas, scikit-learn, TensorFlow, PyTorch, and strong community support have made it the default for everything from data analysis to building complex neural networks.
So Python sounds absolutely non-negotiable. What happens if someone tries to navigate this field without that foundational Python mastery? What kind of limitations would they hit? Is it even possible?
It would be a significant roadblock. I mean, while you can use some AI tools with graphical interfaces without coding to genuinely build, customize, or debug AI systems, Python is your baseline. Without it, you're limited to very basic, off-the-shelf applications.
Okay. So baseline Python. Is there anything else on the programming front?
Well, proficiency in a lower-level language like C++ can be a significant differentiator, especially for performance-critical applications.
Like what?
Think real-time computer vision or robotics, where computational efficiency and speed are paramount. If you're building systems that need to react in milliseconds or handle massive data streams efficiently, C++ becomes incredibly valuable. But Python is the starting point for almost everyone.
Okay, so Python for broad utility, C++ for specialized performance. What else is in this non-negotiable toolkit?
Next is data manipulation and analysis. This is huge. AI models are only as good as the data they're trained on, right?
Garbage in, garbage out.
Precisely. So expertise here means mastery of libraries like Pandas for structuring and cleaning data, and NumPy for efficient numerical computation. You have to be comfortable working with data.
And that's a big part of the job.
Oh, absolutely. A significant portion of any real-world AI project is dedicated to data wrangling, pre-processing, cleaning, feature engineering. An expert must possess deep skills in this area. It's often the less glamorous but incredibly vital part of the work the foundation models are built upon.
So the ability to wrestle with data, clean it up, and get it into shape for the models is paramount.
Got it. What about the actual machine learning libraries themselves? You mentioned some.
Yeah. A practitioner needs a deep, practical understanding of frameworks like scikit-learn for classical machine learning algorithms, things like regressions, decision trees, clustering.
The workhorses.
Exactly. Beyond that, for deep learning, the dominant frameworks are TensorFlow and PyTorch.
Those two always come up? They do. And expertise here goes far beyond just knowing how to import a library. It involves understanding model architecture, knowing how to do hyperparameter tuning effectively, and grasping the trade-offs between different approaches and models.
Right.
You have to understand why you're choosing one over the other and how to optimize it for the specific problem.
That's where the theoretical foundation we discussed earlier really comes into play, isn't it? Understanding those trade-offs and the why.
Yes, absolutely. It all connects.
And what about handling truly massive data sets? We hear about big data all the time.
Right. For organizations handling massive data sets, we're talking petabytes, not just gigabytes. Familiarity with big data technologies is critical.
Like Spark.
Apache Spark is the big one. Distributed computing frameworks like Spark are essential for building scalable data pipelines and training models on large-scale data. If you're going to deploy AI in a big enterprise, especially one with a lot of legacy data, you'll almost certainly encounter these tools.
Okay, so these foundational pillars, formal education, a smart portfolio of certifications, and these core technical competencies, they form the baseline. They're the table stakes, as you said. But we know AI is constantly evolving and diversifying. So what comes next? Where does expertise really differentiate?
Exactly. These are the table stakes.
Uh,
But true expertise in AI, a rapidly evolving and diverse field, almost always involves specialization. You rarely find a generalist AI expert who is truly world-class across all subfields.
it's just too broad now.
It's just too vast and deep for one person to master everything at the highest level. So specialization becomes key.
That makes a lot of sense. The field has just become too vast. So let's move into the spectrum of specialization. We'll start with one of the most talked about areas right now, expertise in language and generation, which covers natural language processing, or NLP, and generative AI. Huge buzz here.
Huge buzz is right. This domain, as you said, focuses on enabling machines to understand, interpret, and generate human language. It's been fundamentally reshaped by the advent of the transformer architecture and the subsequent rise of large language models, or LLMs.
Transformers really changed the game.
Completely.
Huh.
A credible expert here needs a multi-layered skill set. It's not just one thing.
Okay. What are those layers? Is it just about knowing how to prompt something like ChatGPT or Claude?
Far from it.
Right.
That's useful. But it's the tip of the iceberg. It starts with foundational NLP, which includes classical techniques like tokenization, stemming, lemmatization for text preprocessing.
Breaking words down.
Essentially, breaking down words to their root forms.
Yeah.
And also text representation methods like TF-IDF and Word2Vec, which are ways to turn human language into numerical data that machines can actually understand.
Right. Vectorizing text.
You need to understand how human language is broken down and represented in a way machines can process. That's the base layer.
So the building blocks, and then the deep learning part.
Huh.
That seems critical now.
Building on that is a deep understanding of deep learning for NLP. While recurrent neural networks, RNNs, and long short-term memory, LSTMs, were once central for processing sequences.
I remember those being the hot thing.
They were. But the most critical element now is a thorough grasp of the transformer architecture that underpins all modern LLMs. If you don't understand how transformers work, their attention mechanisms, you're missing the core innovation of the last, say, 5 or 6 years in NLP.
So understanding transformers is non-negotiable for deep NLP work now. And then the headline grabbers, generative AI and LLMs themselves, what does real expertise look like there beyond just foundational knowledge?
Okay, so for contemporary roles, hands-on proficiency with generative AI and LLMs is paramount. This means working with state-of-the-art models like OpenAI's GPT series, Meta's Llama family, Anthropic's Claude, Google's Gemini, and others.
Knowing the landscape.
Knowing the landscape and working with them. It's not just theoretical. It includes practical skills in API integration, model fine-tuning that's adjusting a pre-trained model for a specific task or data set, and implementing advanced techniques like retrieval-augmented generation, or RAG.
Oh, RAG is a big one right now, for sure. Can you briefly explain why RAG is so important?
Yeah, RAG is crucial because it grounds LLMs in specific, often proprietary data sources. It helps prevent them from hallucinating or making things up and ensures the answers are relevant and accurate, especially in enterprise contexts where you need factual reliability based on your company's knowledge.
That makes sense. It tethers the creativity to facts. And of course, everyone is talking about prompt engineering. Is that truly an expert skill or just, clever wording?
It absolutely is. Prompt engineering is the newly essential art and science of crafting inputs that elicit the most accurate, relevant, and useful outputs from generative models.
Art and science, huh?
Yeah, it's about understanding the nuances of how these models interpret language and developing sophisticated strategies to guide their responses effectively. It's more complex than it looks.
Okay. And frameworks. Are there specific tools experts need here?
Definitely. Proficiency in the dominant frameworks of the field, especially the Hugging Face Transformers library, is basically non-negotiable for any serious practitioner. Alongside that, tools like Spacey and NLTK for more classical NLP tasks are also important.
Hugging Face seems central.
It's become the de facto standard for accessing and working with pre-trained models.
That's a lot, and it sounds like a fast-moving target. I've heard you mention before that some skills have a shorter half-life than others. Does that apply here in generative AI? Is this knowledge decaying quickly?
This is a perfect example of the recency filter in action. Expertise in generative AI is highly volatile. Knowledge that is even a year or two old can be significantly outdated due to the incredibly rapid advancements in models, techniques, and even the dominant frameworks.
Wow, a year or two is nothing.
It's incredibly fast. So when validating a generative AI expert, the recency of their experience, their engagement with current research papers, their activity in the community, and their demonstrated commitment to continuous learning is paramount. You have to be constantly learning in this space.
Fascinating and a bit scary. So what about the other side of the coin, the visual aspect? Let's talk about expertise in perception and vision, or computer vision. How does that compare?
Computer vision, CV, is the subfield dedicated to enabling machines to derive meaningful information from visual inputs like images and videos. Expertise here demands a strong dual foundation, blending classical image processing techniques with modern deep learning approaches.
Okay, so a mix of old and new. What are the key skills someone needs in this area?
It starts with image processing fundamentals. This includes techniques for manipulating and enhancing digital images at the pixel level. Things like filtering to reduce noise, edge detection to find boundaries, and image segmentation to partition an image into meaningful regions.
The basic toolkit for handling images.
Exactly. These are the building blocks for preparing visual data for more advanced analysis. But the core of modern CV lies in convolutional neural networks, CNNs, and their architectures.
CNNs. The workhorse of vision.
Absolutely. A true expert must possess deep knowledge of CNNs and their many variants architectures like ResNet for handling very deep networks, or YOLO for real-time object detection. And they need to be able to apply them effectively to core CV tasks like image classification, object detection, and semantic segmentation.
So understanding not just what a CNN is, but the different types and what they're best used for, the trade-offs. And what about applications beyond just looking at static pictures, like in robotics or AR?
Good question. As applications for CV expand into robotics, autonomous vehicles, and augmented reality AR, expertise in 3D vision and geometry is becoming an important differentiator.
3D. Okay, what does that involve?
This includes skills in 3D reconstruction from 2D images, camera calibration techniques, and understanding stereopsis, how we perceive depth from two eyes or two cameras.
Yeah.
These are essential for systems that need to interact with the physical world in 3 dimensions.
Makes sense for self-driving cars or robotic arms?
Precisely. And of course, mastery of the relevant frameworks and libraries is crucial. Proficiency in OpenCV is a fundamental requirement for classical image processing tasks.
OpenCV is everywhere in vision.
It really is. And then deep expertise in PyTorch or TensorFlow is necessary for building and training the deep learning models, the CNNs we talked about.
Okay. This highlights how these skills are fundamental to applications interacting directly with our physical world, from self-driving cars to medical image analysis to industrial automation. Now, let's move to perhaps the most complex and specialized area, mathematically speaking, expertise in strategy and control, which is reinforcement learning.
Right. Reinforcement learning, or RL, is arguably one of the most mathematically intensive and conceptually distinct subfields of AI. It focuses on training agents, think of them as learners or decision makers, to make a sequence of decisions in an environment to maximize a cumulative reward.
Learning by doing, essentially.
Exactly. Unlike supervised learning, RL doesn't rely on labeled data telling it the right answer for each step. It learns through trial and error, figuring out what actions lead to good outcomes over time, much like how a child learns to ride a bike.
So less about classifying data, more about learning a strategy.
Precisely. And expertise here is demonstrated less by familiarity with specific tools, although that matters, and more by a profound theoretical understanding of its core mathematical framework. The theory is really key in RL.
So it's really about the underlying theory. What's the bedrock here that someone needs to master? What's the equivalent of understanding transformers in NLP?
The absolute bedrock of RL expertise is a mastery of the Markov decision process, MDP. This is the mathematical framework used to formally model decision-making in these sequential, uncertain environments.
MDPs. Okay.
A genuine expert must be fluent in the language of MDPs. This includes concepts like states, where the agent is, actions, what it can do, policies, its strategy, value functions, how good a state or action is, the discount rate, valuing immediate versus future rewards, and the Bellman equation.
Ah, the Bellman equation. Heard of that.
It mathematically describes how optimal decisions are made over time, by relating the value of a state to the values of successor states. If someone can't speak fluently about these core concepts, can't explain the Bellman equation intuitively, their RL understanding is likely superficial.
That sounds incredibly foundational and abstract, very math-heavy. What about the algorithms themselves, beyond the MDP framework?
Beyond the theoretical foundations, an expert must have a working knowledge of the core algorithms that drive the field. This includes value-based methods like Q-learning, policy-based methods like policy gradients, and model-free methods like Monte Carlo approaches. Each has its strengths and weaknesses.
And there's a key challenge in RL, isn't there? Something about exploring versus exploiting.
Yes. A key indicator of deep understanding is the ability to articulate the nuances of the exploration-exploitation trade-off. This is the central challenge in RL.
How so?
Well, an agent must balance between exploiting actions it already knows yield good rewards and exploring new, untried actions that might lead to even better rewards in the future. Too much exploitation, and it gets stuck in a rut. Too much exploration, and it never capitalizes on what it's learned.
Finding that balance sounds tricky.
It's a delicate balance that defines successful RL systems, and knowing how to manage it is crucial.
That makes perfect sense. You can't just keep doing what you know works, but you can't just explore endlessly without using what you've learned. How does deep RL fit into this, combining deep learning with RL?
In modern applications, especially those with complex inputs like video games or robotics, the ability to implement deep RL is essential. This combines RL algorithms with the power of deep neural networks to handle high-dimensional state spaces, like the pixels of a video game screen, or complex robot sensor data.
So using neural networks to represent the policy or value function.
Exactly. Typically using frameworks like PyTorch or TensorFlow, this brings RL into the realm of complex real-world problems that were previously intractable. Think AlphaGo beating the world champion. That was deep RL.
Right, a huge milestone. This raises an important question. You talked about the recency filter for generative AI being very short, maybe a year or two. How does that compare for reinforcement learning? Is the knowledge equally volatile? Does that MDP stuff go out of date?
That's a great question, and it highlights a critical difference across AI domains. Unlike generative AI, foundational RL understanding, such as the concepts covered in Sutton and Bartow's foundational textbook on RL, which is sort of the Bible of the field.
Yeah, I've seen that referenced everywhere.
Right. That knowledge remains a powerful signal regardless of when it was acquired. The core principles and mathematical framework of RL, the MDPs, the Bellman equation, the exploitation dilemma, have a much longer half-life because they are deeply theoretical and fundamental.
Interesting.
This highlights the differing half-lives of skills across these various AI domains. Some knowledge is evergreen, while other areas require constant real-time updates just to stay relevant.
That's a critical distinction for anyone trying to assess expertise. It's not a one-size-fits-all approach regarding how current someone needs to be. Now, beyond the purely technical, you mentioned something called interdisciplinary acumen. What does that mean for an AI expert, especially as AI systems become more powerful and integrated into, well, everything?
This is where the rubber really meets the road, especially for more senior roles or roles focused on deployment. As AI systems become more deeply integrated into the fabric of business and society, purely technical expertise is proving to be insufficient.
Not enough just to build the model.
Not anymore, no. The most valuable and impactful AI experts are those who complement their deep technical skills with an understanding of human and organizational contexts. They're not just building models in isolation, they're building solutions for people within organizations, in society.
So it's not just about building the model, but how it fits into the broader world and the organization. What are some examples of this crucial interdisciplinary acumen? What skills are we talking about here?
Okay, a critical emerging competency, maybe the most critical, is AI ethics. Understanding concepts like fairness, accountability, transparency, and identifying potential bias is no longer a soft skill or something you delegate. It's a core requirement for responsible AI development and deployment.
So an expert needs to be able to talk about bias mitigation.
Yes. An expert must be able to identify potential sources of bias in data sets and algorithms and articulate strategies for mitigation. This isn't optional anymore. It's an integral part of risk management and building trust with users and the public.
That's a huge shift in perception, moving ethics from a philosophical discussion to a core engineering requirement for practitioners. What else falls under this interdisciplinary umbrella?
Equally important, especially in business settings, is business strategy. The ability to connect a proposed AI solution to a specific measurable business problem, define clear success metrics, KPIs, and articulate the why behind an initiative is a hallmark of a senior expert who can drive tangible value, not just build technically interesting models in a vacuum.
Linking the tech to the bottom line.
Absolutely. And this is often amplified by domain-specific knowledge. An AI expert with a deep understanding of a particular industry, say finance, healthcare, or manufacturing, is exponentially more valuable.
Why is that?
Because they can navigate the unique data landscapes, the specific regulatory constraints, and the operational realities of that sector. They understand the nuances that a purely technical person, even a brilliant one, might miss. This enables them to design and implement truly effective, context-aware solutions.
So, combining the technical prowess with the strategic, ethical, and domain-aware mindset, it sounds like a truly well-rounded expert. A bit of a unicorn, maybe?
They can be hard to find, but knowing is one thing. The ultimate validation, I'd imagine, comes from demonstrable impact, what an expert has actually built and the value it has created. The proof, right?
Absolutely. Show me your results.
Exactly. In an industry characterized by a, let's be honest, high rate of project failure, with some reports suggesting that maybe 70–80% of AI initiatives fall short of their goals.
That's a sobering statistic.
It is. Yeah. And because of that, a tangible portfolio of successful, impactful work is the most reliable and definitive validator of expertise. While credentials signal knowledge, a portfolio provides undeniable proof of application and value creation. It's the difference between knowing how to use a hammer and actually building a house that stands up.
Well put. So, how do we measure that success? What are the key metrics for evaluating AI implementations? How do we know if the house is standing?
A successful AI implementation isn't just a functional model running somewhere. It's a solution that gets adopted by users, integrates into workflows, and delivers measurable, meaningful value back to the organization.
Okay.
We can categorize success metrics into two broad buckets: hard ROI, which measures direct financial impact, and soft ROI, which captures organizational and user-centric benefits.
Let's start with hard ROI. That usually gets people's attention. What kind of direct financial impact are we talking about, and why is that the first thing to look for?
Well, when assessing impact, direct financial return is often the most compelling argument for AI investment, especially to executives. The most common and compelling forms of AI-driven value are cost savings and efficiency gains.
How does AI achieve that?
Through things like automation of repetitive tasks, optimization of complex processes to cut operational costs, and general workflow enhancements to increase throughput or speed.
Have any examples?
Sure. There are case studies like Mayer, an engineering firm, saving over 800 working hours per month using Microsoft 365 Copilot for tasks like summarizing meetings and drafting documents. Or AES, an energy company, reportedly reducing safety audit costs by an astounding 99% using Google Cloud's Vertex AI for image analysis of infrastructure.
Wow, 99%. Those are truly compelling numbers. What about increasing revenue, the other side of the coin?
AI can be a powerful engine for revenue growth. This can come from personalization engines that increase sales and click-through rates. Think about Amazon's recommendation engine, or eBay boosting sales by about 10% with machine learning, according to reports.
Right.
It also includes creating entirely new revenue streams from novel AI-powered products and services. And then there's error rate reduction.
How does that translate to ROI?
In many business processes, errors are costly. They lead to rework, customer dissatisfaction, wasted materials, or even regulatory fines. AI systems that can reliably reduce these errors deliver tangible financial value. Bank Center Credit, for instance, used AI to reduce errors in its financial reports by 40%, leading to more reliable analytics and faster, better-informed decision-making.
Those are all very clear, quantifiable impacts, easy to put in a spreadsheet. But you also mentioned soft ROI. How do we measure the human and strategic impact, which can be harder to pin down, but still really important?
They are harder to quantify sometimes, but these metrics are often leading indicators of long-term value and sustainability, even if they aren't immediately reflected in the quarterly balance sheet. First, user adoption and experience.
Meaning, do people actually use the thing?
Exactly. A technically brilliant AI tool that no one uses because it's too complex or they don't trust it or doesn't fit their workflow is ultimately a failure. So metrics gauging user engagement and satisfaction are critical. Things like customer satisfaction, CSAT scores, net promoter scores, NPS, or internal employee adoption rates for new AI tools.
Right.
A successful project means users actively integrate the AI tool and find it genuinely valuable in their daily work.
So it's about whether people actually want to use the AI and find it helpful. Beyond the end user, how does well-implemented AI impact the employees themselves? Does it really make their lives better or just add more complexity?
That's a crucial question. AI that's thoughtfully implemented can significantly improve employee satisfaction and retention by automating the mundane, repetitive tasks that people often dislike.
The drudgery.
Exactly, the drudgery. AI frees up individuals for more creative, strategic, and engaging work. This can lead to a measurable boost in morale, engagement, and ultimately retention, a key soft ROI that contributes to a healthier, more innovative organization. And retaining good people is incredibly valuable.
Definitely. Anything else on the soft side?
Yes, strategic alignment is crucial. The most successful AI projects aren't just cool tech demos. They are tightly aligned with a core business objective. They solve a clearly defined strategic problem, not just serve as a technology experiment.
So avoiding AI for AI's sake.
Precisely. An expert who understands how to frame AI in the context of strategic goals and ensures the project delivers on those goals is delivering lasting value that contributes to the organization's overarching mission.
This highlights why these metrics, both hard and soft, are essential for justifying AI investments and predicting long-term value. If you can't measure the value, you can't justify the investment, nor can you iteratively improve the AI solution based on feedback.
Precisely. They provide the empirical evidence needed to demonstrate value, secure future funding, and ensure AI isn't just a cost center, but a genuine value driver for the organization.
Now, beyond these corporate implementations documented in case studies, how does an individual build a public portfolio of proof? What are the different ways someone can demonstrate their impact to the broader AI community or potential employers?
That's a great point. An individual's public contributions are often a more authentic and reliable indicator of skill than a self-reported resume because they're verifiable. One of the most powerful signals is open source contributions.
Getting involved in GitHub projects and things like that.
Exactly. The open source movement is the lifeblood of modern AI, fostering rapid innovation and collaboration. Active contribution to major projects like TensorFlow, PyTorch, Hugging Face libraries, scikit-learn, or infrastructure tools like Ray is a profound statement of technical capability and collaborative spirit.
So it's not just about downloading and using open source tools, but actively giving back, fixing bugs, adding features. That seems like a high bar.
It is a high bar, and that's why it's such a strong signal. When evaluating these contributions, you look beyond mere participation, like fixing a typo in the documentation. The key is to assess their significance.
What counts as significant?
Did the individual fix a critical bug affecting many users? Did they implement a sought-after new feature? Did they author a widely used library or tool themselves? A well-maintained GitHub profile that documents significant high-quality contributions is one of the strongest possible assets for an applied AI professional. It shows they can build, test, document, and collaborate in a transparent, verifiable way.
That sounds like a powerful signal of genuine expertise and commitment. What about for those in more research-oriented roles? Is GitHub as important?
For research-oriented experts, while open-source contributions are still valuable, especially releasing code for papers, the primary currency is peer-reviewed publications in top-tier academic conferences and journals.
Right, the publish-or-perish world.
To some extent, yes. The AI research community has a clear hierarchy of prestigious venues. We're talking conferences like NeurIPS, ICML, ICLR for Core ML, CVPR for Computer Vision, ACL for NLP, and top journals like the Journal of Machine Learning Research, JMLR.
And why are these publications such a strong signal?
Because the rigorous multi-stage peer review process at these top venues acts as an extremely effective filter. Getting a paper accepted means multiple experts in the field have judged the work to be original, technically sound, methodologically rigorous, and impactful.
Yeah.
It's a tough bar to clear.
So the venue really matters. Just having a publication isn't enough. It needs to be in a reputable place. Anything else to look for when assessing a publication record?
Yes, the venue is paramount. A paper in NeurIPS carries exponentially more weight than one in a lesser-known workshop or journal. Further indicators of influence include the individual's role on the paper-first authorship, typically signifies the primary contributor who did most of the work, and the paper's citation count over time, which serves as a proxy for its impact and influence on subsequent research in the field.
Makes sense. And what about something a bit more informal, like personal projects or maybe even Kaggle competitions? Do those really count in a portfolio?
Personal projects and public demonstrations are also powerful validators, especially for applied roles, or for individuals perhaps earlier in their careers.
How so?
A well-documented personal project showcasing the ability to take an idea from conception through data collection, model building, deployment, and evaluation can be incredibly compelling. It shows initiative, passion, and end-to-end execution skills.
So building something cool on their own time.
Yes, and documenting it well, perhaps on GitHub or a personal blog. Similarly, achieving a high ranking in a competitive Kaggle competition demonstrates practical problem-solving skills on real-world datasets under pressure.
Kaggle's pretty intense, right?
It can be, yes. And even maintaining a technical blog where someone clearly and accurately explains complex AI concepts can signal deep understanding and, importantly, strong communication skills, which are also vital. For many applied roles, these demonstrations of initiative, passion, and end-to-end execution can be just as valuable as more traditional credentials.
This raises an important point about hype versus impact. It sounds like there are a lot of people out there with high hype scores, maybe great communicators, very visible, but relatively low actual impact scores based on these proofs. How do we avoid falling for the hype?
You've nailed it. The market is saturated with individuals who have a strong social media presence, a knack for using the latest buzzwords, and maybe a polished speaking style, a high hype score.
Yeah, you see them online.
But their impact score, measured by quantifiable business results, significant open source contributions, or highly cited papers in top venues, might be quite low. The most credible experts are those for whom this ratio is inverted. High impact, maybe lower hype?
So focus on substance over style.
Absolutely. An effective vetting process must actively discount hype and demand tangible proof of impact. The crucial question to ask a potential expert, whether hiring or collaborating, is not just what do you know, but what have you built, what value did it create, and how can you prove it? Ask for the specifics, the metrics, the code, the papers.
So the proof is truly in the pudding, or the portfolio in this case. And I imagine the ideal portfolio of proof differs for different types of AI roles. A researcher needs different proof than an engineer.
Exactly. The ideal portfolio for an AI research scientist is fundamentally different from that of an applied AI engineer or an MLOps specialist. The researcher is validated primarily by a strong publication record in top venues, demonstrating an ability to create novel knowledge and advance the field.
Okay.
The applied engineer, on the other hand, is validated more by a portfolio of shipped products, successful implementations with clear ROI, and perhaps meaningful contributions to open-source engineering projects that others use. The MLOps person might highlight scalable deployment architectures they built.
Right. Different goals, different evidence.
You can't apply a one-size-fits-all model. You must tailor your validation criteria based on the primary function and goals of the specific role you're evaluating someone for.
This all makes so much sense for evaluating individuals. But individual expertise doesn't exist in a vacuum, does it? We've hinted at this. The success or failure of AI depends so heavily on the organizational environment. Let's talk about the organizational context. Leadership, culture, and change. How does that fit in?
You're absolutely right. It's a critical piece, often the deciding factor.
Mm-hmm.
A brilliant AI scientist placed in a risk-averse culture with poor data infrastructure and absolutely no executive support is almost certainly going to fail, or at least be deeply frustrated and ineffective.
Right, the environment can stifle even the best talent.
Completely. A true expert, especially when you're talking about senior levels, must be more than just a technologist. They must be an organization builder, or at least an effective influencer within the organization.
What do you mean by organization builder?
Their ability to provide strategic vision, to help cultivate an AI-ready culture, and to navigate the complexities of organizational change management is a critical and often overlooked component of their overall expertise and potential impact. It's about making the organization receptive to what they can offer.
So what does an effective AI leader look like? Are there different archetypes or styles of leadership that emerge in this space depending on what the organization needs?
Yes, definitely. The ideal AI leader depends heavily on an organization's current AI maturity, its strategic goals, and its culture. We can broadly identify two main archetypes, though individuals can blend these.
Okay, what's the first one?
First, you have the AI industry shapers. These are often the big-picture visionaries focused on the long-term societal impact of AI. They're frequently thought leaders, academics turned industry figures, or advocates for responsible AI. They help organizations navigate the future and set bold strategic directions.
Can you give an example?
Think of someone like Meta's Yann LeCun or Stanford's Fei-Fei Li. They're best suited for setting a bold strategic direction, championing ethical innovation, and representing the organization externally, often at a very high C-suite or advisory level.
Okay, the visionaries. And the second archetype, more hands-on.
Exactly, the AI builders. These leaders are often deeply technical, maybe emerging from a background in hands-on research and development. They are the architects behind the cutting-edge AI solutions, the proprietary models, the core technological breakthroughs.
Like the engineers who built the foundations.
Right. Individuals like DeepMind's David Silver, who is a key figure behind AlphaGo, or OpenAI's former chief scientist Ilya Sutskever, kind of fit this mold. They are essential for organizations that aim to innovate at the core technology level, building the foundational models and systems that power new products and services. They lead the R&D efforts.
So, visionaries and builders. Different styles for different needs. But regardless of archetype, what are the essential attributes common to all effective AI leaders? What defines someone who can truly lead an AI initiative to success within an organization?
That's a key question. There are a few attributes that seem crucial across the board. First, they need a clear vision and business case. They must possess the strategic foresight to connect every AI initiative to a tangible business outcome, avoiding those technology experiments just because AI is cool.
Always linking back to the why.
Always. They articulate a compelling why that aligns AI efforts with overall enterprise goals. This top-down vision and alignment is a critical predictor of success. They also need courage and risk-taking.
Why courage?
Because AI transformation often demands a willingness to challenge established processes, question long-held beliefs, and experiment with bold ideas. It requires embracing uncertainty and being willing to reimagine the art of the possible within an organization which can face resistance.
That makes sense. AI is inherently experimental and often disruptive to the status quo. What about managing the human element when you're introducing something so new and potentially scary?
Absolutely crucial. They must excel at fostering trust and transparency, recognizing that AI can be a source of anxiety or misunderstanding for employees and customers. Great leaders communicate openly and proactively about AI's purpose, its capabilities, its limitations, and its potential impact.
How do they build that trust?
By establishing formal, responsible AI frameworks, involving employees in the process where appropriate, and building the psychological safety needed for confident adoption rather than fearful resistance. Finally, they need a transformational mindset.
Meaning?
The most impactful leaders don't see AI as just a tool for incremental improvement, like making an existing process 10% faster. They see it as a catalyst for fundamental business transformation, aiming to potentially rewire how the company operates, creates value, and competes, not just tweak existing workflows.
It's clear why strong strategic AI leadership is such a critical predictor of success. It's about more than just the tech. It's about translating that technical prowess into real, sustainable organizational value. But leadership needs fertile ground to grow, right? What does an AI-ready culture actually look like? How does an organization cultivate an environment where AI can actually flourish, not just sputter out?
That's exactly right. An AI-ready culture is the necessary foundation, the soil in which AI initiatives take root and flourish. Without this cultural foundation, even brilliant projects led by capable people are likely to stagnate or fail due to organizational friction, resistance, or lack of support.
So what are the key elements of this culture? What does it feel like?
Several things stand out. First and foremost is data-driven decision-making. An AI-ready organization truly treats its data as a core strategic asset. This means having robust strategies and practices for ensuring data quality, accessibility, and governance.
And leaders need to use it.
Yes. Leaders must walk the talk by visibly using data and AI-driven insights in their own decision-making processes, setting an example for the rest of the organization. It can't just be something the data science team does.
So the data has to be good, accessible, and people, especially leaders, have to actually use it in their decisions. What else is part of this fertile ground for AI?
A culture of experimentation. AI development, especially cutting-edge AI, is inherently iterative, and uncertain.
Hmm.
You don't always know if something will work until you try it.
So failure has to be okay.
Exactly. A culture that provides psychological safety for employees to try things, to fail fast on small scales,
Hmm.
and crucially, to learn from those failures without fear of blame is essential for fostering the innovation that AI promises. If failure is punished, people won't take risks.
Makes sense. What about skills across the board?
Pervasive AI literacy and upskilling is vital. To build broad-based trust, understanding, and capability, organizations must invest in educating the entire workforce, not just a small cadre of technical experts, on AI fundamentals.
Why the whole workforce?
This builds a common language, demystifies AI, reduces fear, and empowers employees in all functions to identify potential AI opportunities within their own workflows and collaborate effectively with technical teams. It makes everyone part of the AI journey.
So it's about getting everyone on board and speaking the same language, not just the technical team. And given the transformative nature of AI, how does ethics factor into the culture itself?
Yes, it needs to be embedded. Embedded ethical governance. A formal, transparent framework for the responsible and ethical use of AI is not an afterthought or a compliance checkbox. It needs to be a foundational element of an AI-ready culture.
What does that look like in practice?
It means having clear principles, review processes, and accountability structures. This proactively builds trust with both employees and customers, and is critical for mitigating the significant legal, reputational, and societal risks associated with widespread AI deployment. It demonstrates a commitment to doing AI the right way, not just the fast way.
What are the consequences if an organization fails to cultivate this cultural foundation? If they focus only on the tech hires and neglect the culture, the data, the literacy?
The consequences are typically severe and predictable. Projects will stagnate or fail, often after significant investment. Adoption rates for new AI tools will be low. The organization will miss out on AI's transformative potential while competitors pull ahead.
And talent.
They risk losing top AI talent who will become frustrated and leave for more forward-thinking companies. Ultimately, it's a recipe for expensive, high-profile failures and a severe lack of real business impact from AI investments. The culture eats the strategy and the tech for breakfast.
That's a stark warning. This brings us to a crucial, and you said often underappreciated role, the project leader as a business translator. Who is this person and why are they so important?
This individual, often titled an AI project manager, product manager, or maybe even a program lead, serves as the vital bridge between the deep technical experts, the data scientists, the engineers, and the business stakeholders, the executives, the operational managers, the end users.
The go-between.
Exactly. Their core role is to ensure that the two sides are aligned, speaking the same language, and working towards the same goals. The high failure rate of AI projects, that 70–80% figure, is often attributable to a breakdown in this translation layer, where technical brilliance doesn't connect with actual business needs or realities.
So what essential cross-functional skills do these business translators need to bridge that gap effectively? What makes them good at this?
It's a unique blend. First, they need strong data literacy. While they don't need to be PhD data scientists, they must understand the basics of data sourcing, cleaning, quality assessment, and the potential for bias in data.
Why is that important for a manager?
This allows them to collaborate effectively with technical teams, ask the right questions, understand limitations, and help de-risk projects by identifying data challenges early on. Most importantly, though, cross-functional communication is paramount.
The translation piece.
Yes. They must be adept at translating complex technical concepts like model uncertainty, confidence scores, or specific data requirements into clear business implications for stakeholders. And conversely, they must translate high-level, sometimes vague business requirements into precise, actionable technical specifications for the data science and engineering teams. It's about speaking both tech and business fluently and mediating between them constantly.
They're like interpreters for the AI world, bridging two different cultures. What else defines a good translator?
They also need strategic thinking. A key responsibility is to work with business leaders to clearly define the problem to be solved before jumping to solutions, and critically, to prioritize potential AI use cases based on a pragmatic assessment of potential ROI, strategic alignment, and technical feasibility. Not every problem needs or is ready for an AI solution.
So they need to be able to say no sometimes.
Absolutely. Or not yet. And finally, they need an agile and iterative mindset. AI projects are often not like traditional software development with fixed requirements up front. They're frequently exercises in scientific discovery with uncertain outcomes and evolving understanding.
So adaptability is key.
Very much so. A successful leader in this space must be comfortable managing evolving scope, prioritizing iterations based on continuous learning and feedback, and balancing the need for rigorous experimentation with practical business timelines and budgets. It's a constant juggling act.
So what does this all mean? If we connect this back to the bigger picture, it sounds like the immense challenge of AI adoption is ultimately human, not primarily technical. Is that fair to say?
I think that's a profound and increasingly accurate insight. While the technical challenges are real and significant, the high failure rate of AI projects, combined with the rapid pace of change, is creating a significant premium for individuals who combine technical understanding with deep expertise in change management.
The people side of AI.
Exactly. The ability to manage the human element of transformation, to build trust, communicate a compelling vision, manage expectations, address fears, and guide people through uncertainty is becoming a top-tier skill. This expertise in being an AI change agent is arguably rarer and, in many organizational contexts, potentially more valuable than pure technical prowess alone, because it is the key to unlocking the true value of the technology at scale. Without it, the tech often stays locked in the lab.
That's a powerful statement. It's about getting people ready for AI and guiding them through it. Okay, we've covered so much ground here, from foundational knowledge and specialized skills to demonstrable impact through portfolios, and now the critical organizational context of leadership, culture, and translation. How do we bring this all together into a unified framework for assessing AI expertise in a practical way?
It's a lot to juggle, right? So, to provide a comprehensive and nuanced assessment, we propose evaluating expertise across 4 distinct but interconnected quadrants. Think of it like creating a spider chart profile for a candidate, or even for yourself.
A spider chart. Okay, visualize that.
Yeah, it visually represents strengths and weaknesses across these different dimensions, mapped against the specific needs of a role. This moves us beyond a simple binary expert-not expert judgment, which is often too simplistic for AI. Imagine 4 spokes radiating from a center point, each representing a key dimension of expertise.
Okay, I can picture that. Let's break down this AI expertise validation matrix. What's in quadrant 1, the bedrock? What's that spoke represent?
Quadrant 1 is foundational knowledge, the bedrock. This assesses the theoretical and technical baseline we talked about earlier. It looks at formal education in relevant fields, CS, math, stats, core mathematical understanding, proficiency in the non-negotiable toolkit, Python, Pandas, NumPy, Core ML libraries, and maybe foundational certifications that signal a baseline of conceptual knowledge.
So the fundamentals.
Exactly. The question it answers is, do they possess the fundamental theoretical and technical literacy required to operate effectively in the AI domain? Do they have the basics covered?
And quadrant 2, that's where the deep specialization comes in, right? Going deep on one of those spokes.
Precisely. Quadrant 2 is specialized mastery, the depth. This evaluates deep, domain-specific knowledge in a particular AI subfield relevant to the role NLP, computer vision, reinforcement learning, maybe AI ethics, or MLOps.
Nice you assess that.
Assessment focuses on familiarity with state-of-the-art models and techniques in that niche, core algorithms specific to the domain, specialized frameworks like Hugging Face for NLP or OpenCV for CV, and crucially, the ability to discuss the nuanced trade-offs of different technical approaches within that specialty. The question it answers is, are they a genuine, deep expert in the specific domain most relevant to the role's needs?
Then quadrant 3 is all about the proof, isn't it? The real-world results, the portfolio.
Yes, quadrant 3 is demonstrable impact, the proof. This is the quadrant of tangible evidence, moving from knowing to doing. It scrutinizes the candidate's portfolio of work, looking for verifiable proof of successful application.
What kind of proof?
This includes detailed case studies of past projects with measurable hard and soft ROI, significant contributions to reputable open-source projects, and for research roles, a strong publication record in top-tier peer-reviewed venues. Personal projects with clear outcomes also fit here. The question it answers is, have they successfully applied their knowledge to create verifiable, tangible value, and can they articulate that impact clearly?
And finally, quadrant 4, the human and organizational element we just discussed. How does that fit into the matrix? What's that spoke?
Quadrant 4 is leadership and human factors, the multiplier. This quadrant measures the skills that enable an expert to scale their impact across an organization, multiplying the value of their technical skills.
So communication, strategy.
Yes. It assesses capabilities and strategic vision, cross-functional communication, stakeholder management, influencing skills, and the ability to foster an AI-ready culture. For senior roles, it also evaluates expertise in AI-specific change management and championing ethical governance. The question it answers is, can they lead a team, influence the broader organization, and manage the human dynamics of AI transformation to ensure success at scale.
This holistic approach truly moves beyond simple expert, not expert judgments. It provides a much richer, multidimensional understanding of an individual's capabilities and where they might fit best or where they might need development within an organization. It really helps you pinpoint where someone's strengths truly lie.
Precisely. It's about building a nuanced profile, not just applying a binary label. This depth of understanding is crucial for strategic hiring, team building, and even personal development planning in the AI space.
Building on that, if you're trying to quickly vet someone in an interview, or maybe even just a networking conversation, what are some practical red flags and green flags to look for to help distinguish genuine expertise versus superficiality, quick heuristics?
That's useful, right?
Yeah.
In a market crowded with sometimes exaggerated claims, having some heuristics helps. Let's start with the red flags indicators of superficial knowledge. One common sign is buzzword overload and jargon soup.
Using fancy words they can't explain.
Exactly. If someone relies heavily on complex, trendy terms like synergistic AI paradigms or deep learning hyper-optimization ecosystems without being able to break them down and explain them in simple, concrete terms, it's often a tactic to obscure a lack of fundamental understanding. Or they just read a blog post.
Right. So if they can't explain it simply, they might not truly understand it deeply. What else should raise a warning flag?
Vagueness on tools and models. Generic references like, we use the algorithm, or broad name-dropping like, we leverage ChatGPT as a catch-all answer, instead of discussing the specific libraries, PyTorch, TensorFlow, scikit-learn, specific model architectures like Llama 370B or a specific ResNet variant, or specific techniques they actually use hands-on, is a red flag. A true practitioner will get specific about their tools and methods when prompted.
Okay, lack of specifics. What else?
Dodging practical challenges and limitations. If they present AI as a magical, infallible solution to all problems and actively avoid discussions of project failures, data quality nightmares, model limitations like hallucination or bias or ethical concerns, that's a problem. A genuine expert understands and openly discusses the difficulties, the messy realities, and the trade-offs inherent in real-world AI projects. They've hit roadblocks.
And a lack of humility, I imagine. That suggests a closed mind to learning, which seems fatal in AI.
Precisely. Lack of humility and curiosity. An unwillingness to admit what they do not know, saying, I don't know, but I could find out, is a good sign, actually. But dismissing complex but vital topics like AI ethics by saying, oh, that's for the philosophers, or compliance will handle that, is a significant red flag. The field evolves daily, and true experts are characterized by intellectual humility and a constant desire to learn and challenge their own understanding.
Okay, those are good red flags to watch for.
Yeah.
So what are the positive indicators, the green flags indicators of genuine expertise? What makes you think, this person really gets it?
First, the flip side of jargon, clarity and simplicity. The ability to distill a complex technical concept like how attention works in a transformer, or the bias variance trade-off into a clear and simple explanation understandable by a non-technical audience demonstrates true mastery, not just memorization. It shows they own the concept.
The Feynman technique, right. Explain it simply.
Exactly. Second, look for specific war stories. Genuine experts can recount detailed, specific challenges encountered during a past project. For example, dealing with a badly overfitting model on a small, noisy data set and the precise regularization techniques, data augmentation strategies, or model changes they use to diagnose and fix it. These stories show they've been in the trenches and overcome real, non-trivial problems.
That's a great way to put it, war stories. It shows they've applied their knowledge in a practical, problem-solving way, not just theoretically.
Exactly. It shows experience. Another green flag is a focus on the business problem first. They structure the conversation around the business problem or the user need first, and the technology second. They seek to deeply understand the why, the business context and objective, before jumping enthusiastically into the how, the specific AI technology or model.
Problem first, solution second. Makes sense.
And finally, related to the red flag about dodging limits, an acknowledgement of limits in ethics. They proactively and thoughtfully discuss AI's current limitations, the potential for unintended negative consequences, like bias amplification, and the importance of building fair, transparent, and accountable systems. This shows maturity, responsibility, and a holistic understanding of AI's broader societal impact, not just its technical capabilities.
Those flags, red and green, can really guide your own assessment, whether you're hiring, collaborating, choosing a vendor, or simply trying to understand the AI conversations happening all around you.
Finally, let's zoom out again. What are the strategic recommendations for organizations looking to acquire and develop AI talent effectively? This isn't just about vetting one person, but building sustainable capability across an organization for the long term. What should leaders be thinking about?
That's the million-dollar question, isn't it? Building world-class AI capability is definitely a long-term strategic endeavor. It requires a forward-looking approach that goes beyond just trying to hire a few rock star individuals.
So what's recommendation number one? First, hire for adaptability, above all else. In a field where state-of-the-art tools and techniques can become significantly less relevant, maybe even obsolete, in a year or two, the most critical long-term attribute is not mastery of any specific tool or framework today. It's a demonstrated capacity and intrinsic willingness to continuously learn, unlearn, and pivot to new technologies and approaches. Prioritize candidates with a strong track record of continuous learning and adapting effectively to change. Look for curiosity.
That makes so much sense in such a fast-moving field. Learnability over current knowledge, almost? What else should organizations prioritize?
Invest in upskilling and AI literacy across the enterprise. Don't try to silo all the AI expertise within a small central team. The most successful organizations aim to turn their entire workforce into force multipliers by investing in broad-based AI literacy programs tailored to different roles.
Why is that so important?
This builds a common language, demystifies AI reducing fear, fosters a more data-driven culture organically, and empowers employees in all functions, marketing, sales, HR, operations, to identify valuable opportunities for AI-driven innovation within their own areas of expertise. It creates more eyes looking for opportunities.
Makes sense. Democratize the understanding. What about the impact on jobs?
That's critical. Proactively manage workforce transformation. Major analysts like Gartner and McKinsey predict AI will fundamentally redesign workflows and potentially flatten organizational structures, eliminating some routine tasks and roles, but also creating new, more strategic ones focused on judgment, creativity, and collaboration with AI.
So leaders need a plan.
Yes. Leaders must anticipate this significant shift and proactively manage the transition. This means investing heavily in reskilling and redeploying talent, equipping employees with the skills needed for a future where their primary value lies in creativity, critical thinking, strategic problem solving, and effective collaboration with increasingly capable AI systems. Don't wait for the disruption to happen.
So it's about preparing the entire organization for an AI-powered future, from the ground up, anticipating the changes. And then there's the question of trust and risk, which we touched upon with ethics and governance. How does that translate into a strategic recommendation?
It needs dedicated focus. Build expertise in AI trust, risk, and security management. Two ASM aims. As AI embeds deeper and deeper into critical business processes, making loan decisions, driving cars, diagnosing diseases, a formal, robust governance framework is no longer optional. It's essential for survival.
Tourism trust, risk, and security management.
Yes. Gartner identifies AI tourism as a critical emerging trend. It encompasses the tools, policies, and processes needed for ongoing model monitoring, for drift, bias, performance, data protection and privacy in AI contexts, AI-specific security vulnerabilities, and overall risk control. Organizations must either build internal expertise or acquire external help in this area to ensure responsible, reliable, and sustainable deployment of AI, protecting both the organization and its stakeholders from potentially catastrophic failures.
That sounds like a whole new discipline emerging. It also sounds like the very act of validating AI expertise effectively is itself a specialized skill. So if an organization is starting from absolute scratch, with no internal AI leadership or significant expertise, what's their first most critical step? How do they even begin to hire using this framework?
That's a crucial bootstrapping problem. For an organization with no internal AI leadership or expertise, vetting external talent using the nuanced framework we've discussed is incredibly difficult, almost impossible. This can create a dangerous cycle of hiring unqualified individuals based on hype, leading to subsequent project failures and disillusionment.
The blind leading the blind.
Essentially, yes. The framework we've discussed is most effective when wielded by someone who possesses at least a moderate level of AI literacy and experience themselves. So for an organization starting truly from scratch, the very first AI hire, especially a leadership hire, is the most critical and highest risk decision they will make on their AI journey.
So what should they do?
Such organizations should strongly consider engaging a trusted, vetted third-party advisor, or perhaps appointing a non-executive director with proven AI credentials and industry experience, specifically to help them make this foundational hire correctly. Getting that first strategic leader right can truly set the trajectory for their entire AI journey. Success or failure often hinges on it.
That's a crucial piece of practical advice for any company just beginning this journey. Don't try to fake it on the first hire. And looking ahead now as we wrap up, how do you see the very definition of AI expertise continuing to evolve? What does the AI expert of tomorrow look like? Is it different from today?
I think the definition is likely to evolve significantly and quite rapidly. As powerful foundation models become even more capable and accessible, perhaps through open source releases or increasingly sophisticated commercial APIs and platforms.
The trend seems to be heading that way.
Right. The emphasis for many roles will likely continue to shift away from the ability to build every single model from scratch using low-level tools towards the ability to intelligently leverage, compose, fine-tune, and orchestrate a complex ecosystem of existing AI systems, foundation models, centralized models, data pipelines, APIs.
So less building blocks, more architecture.
In many applied contexts, yes. The most valuable experts of the near future might be what we could call masters of augmentation, or AI orchestrators. These are individuals who can architect robust, cost-effective, scalable, and ethical AI solutions by skillfully combining proprietary data, fine-tuned open-source models, commercial AI services, and traditional software engineering practices to solve the most pressing business challenges.
So it's a higher level integration skill.
Exactly. This represents a higher-order form of expertise, blending deep technical knowledge, they still need to understand how the pieces work, with strong strategic thinking, systems architecture skills, business acumen, and ethical foresight. It's about building value by intelligently connecting the dots.
What a journey we've been on today. We've navigated the complex, often confusing landscape of AI expertise, moving from the foundational knowledge in math and code through the necessary nuances of specialization in areas like NLP or vision, to the undeniable proof needed in a portfolio of demonstrable impact, and finally, landing on the absolutely crucial role of organizational context, the leadership, the culture, the translators.
And we pulled it together with that four-quadrant matrix and the red and green flags. We've aimed to give you a comprehensive toolkit, really, for understanding what truly constitutes AI expertise today, providing you with clarity in what can be a very noisy and hyped-up field.
Absolutely. So here's a final thought for you, our listeners, to mull over as you navigate this space. The AI expert of tomorrow isn't just a coder or a researcher anymore. They're increasingly becoming a masterful orchestrator, someone who can skillfully combine proprietary data, open source models, commercial AI services, and ethical considerations to solve the most pressing business and societal challenges effectively. The question is, what does it mean for you to become, or perhaps more importantly, to identify, such a master of augmentation in this rapidly evolving world?
A great question to ponder.
We encourage you to apply this framework, these ideas, in your own context, whether you're building a team, evaluating a potential vendor or project, or simply deepening your own understanding of AI and who the real experts are. Until next time, on The Deep Dive, keep diving deep.